Okay, ladies and gentlemen, today we're going to talk about comparing functions when they're in two different forms. So you've seen functions that are equations, you've seen functions that are tables, you've seen functions that are graphs. And you know how to switch between a table and an equation, or a graph and a table from the same function. But you probably have never looked at the function of one, or the graph of one function rather, and the equation of another, or the table of one function and the equation of another. So that's what we're going to be working on today. We're looking at two different functions represented different ways, and we're going to be able to compare the slope and the y-intercept of them. Let's take a look at this first example. Here we've got two different functions. We've got f of x, that's the name of this function, and then g of x is the name of this function. F of x is an equation, g of x is a table. So these two functions represent different sets of data, different functions there. So this is not the table that goes along with this equation. They're two completely different things. We can find the slope of both of these. We know how to find the slope of a table, and we know how to find the slope of an equation, and we can compare those two slopes. So let's look at this equation first. We know that in y equals mx plus b, m stands for the slope. So the slope of this function is just 10. The slope of this function is just 10. When we look at the table, we've got to do a little bit more work to find the slope, but we know how to do this as well. Using a table, we use our slope formula after we pick out 2 points. So I'm going to pick the point 0, 10 and the point 1, 15 because I like to pick positive number points. Then I'm going to write my slope formula down here. We've got y2 minus y1 over x2 minus x1 because my slope formula is the only way I know so far to find the slope of a table. When we fill in our slope formula, we're going to take y2, 15, minus y1, 10, over x2, 1, minus x1, 0. So I get 15 minus 10, which is 5, over 1 minus 0, which is 1, meaning I have a slope of 5 divided by 1, or 5. Now I have to say what I've found. So I'm going to say what I've found by making the name of my function. So this function is called f of x, and this function is called g of x. And I want to say that this top function had the bigger slope. So I'm going to name it. I'm going to use its name, f of x. And I'm going to write f of x has the greater slope. So f of x has the greater slope. Since that one had a slope of 10, and this function represented by a table only had a slope of 5. So I want to say which of my slopes is greater there. Let's take a look at the next example. So we've got two functions again, one which is represented by an equation, and the other one which is represented by a table. Again, they're called f of x and g of x, and that shows us that they are two completely different functions there. We can find the slope of f of x very easily because that's just the m value in our mx plus b. So the slope of our equation is 8. So our slope is 8 there. To find the slope of our table, again, we need to use our slope formula. So I'll pick 2 points. I'll pick 2 points that are positive, so maybe 0, 16 and 1, 24. And 1, 24, let me put parentheses around that. And we're going to use y2 minus y1 over x2 minus x1. All right, so when we fill in our information there, y2 is going to be 24 minus y1, which is going to be 16. Then we've got x2 down here, which is going to be 1, minus x1, which is 0. So 24 minus 16 gives me 8. And 1 minus 0 gives me 1. 8 divided by 1 gives me my slope of 8. So what I just found here is I found that our functions have a slope of 8 and a slope of 8. These two functions have the same slope. So I can say f of x, I'll name my first function that's represented by an equation, and g of x, my second function, which is represented by a table, have the same slope. So they have the same slope. All right, so we compared our slopes. We found out that both of those functions have slopes which are the same. Let's take a look at our next example. In our next examples, we're going to compare the y-intercept instead of the slope. So looking down here, we've got two functions again, but in this case, one function is represented by a table, and the other function is represented by a graph. Lucky for us, it's easy to find the y-intercept of a table, and it's also easy to find the y-intercept of a graph. We haven't talked too much about finding the y-intercept of a table before, but it's very simple. All you need to do is you find the 0 in your x category, or in your x column, or x row, because the number that goes along with 0 in your x's is going to be your y-intercept. So if we take a look here, we have 0, -6, which means that my y-intercept, abbreviate y-intercept, is -6. All right, so the y-intercept of that table function is -6. Then we take a look at our graph, and we're going to find the y-intercept of our graph. So again, on a graph, it's pretty simple. All we have to do is we find where our graph crosses the y-axis. Our graph crosses the y-axis at 0, -5, which means my y-intercept is -5. If I wanted to talk about which of my functions has the lower y-intercept, I would name it. So I would say, well, this function up here, it's got a -6. So that function is called f of x. So I would say f of x has a lower y-intercept. The same thing is going to happen in the next example that we've got. We've got two functions, one which is represented by a table and the other which is represented by a graph. So if I look at my table first, I can find my y-intercept very easily by looking along my x row and finding the 0. So here's the 0. It goes along with the number 3. So the y-intercept of that graph, of that table, is 3. So I can say I shouldn't say y equals, that's a different thing. Y-intercept is 3. So I've got that covered. Then I need to find the y-intercept of my graph. And once again, it's the spot where my graph crosses the y-axis. So I take a look down here, crosses right there between 3 and 4. So I think we can call that 3.5. So we can say the y-intercept of that function, which is represented by a graph, is 3.5. If I wanted to talk about the function with a higher y-intercept, I would say, well, this function down here, my bottom graph function, has a higher y-intercept. I look for its name. Its name is g of x. So I can say g of x has a higher y-intercept. Let's take a look at some real-world problems. Again, we've got something that's represented by a equation and one that's represented by a table. So this is two examples of people's hang gliding. It says Fred and Jean are hang gliding. Fred is 700 feet above the ground and descending at 15 feet per second. His equation's given right here. He starts at 700, that's his y-intercept, and his slope is -15 since he's descending. He's getting closer to the ground at 15 feet per second. Jean is descending as shown in the table. So Jean's information is over here in this table. Interpret the rate of change. Rate of change, that's going to be our slope. And initial values, that's going to be our y-intercept of the functions, or of the linear functions, in terms of the situations they model. So we'll take a look and first of all decide what the slope and y-intercept of our friend Fred's equation is up here. So he's got a slope of -15 and a y-intercept of 700. Then we've got Jean's information. We can find the slope by using our slope formula. I'll choose the point 0.575 and 1.565. So there are the 2 points I'll use there. We can take y2 minus y1 over x2 minus x1. So we've got 565 minus 575 over, then we've got x2 is 1 minus x1 is 0. 565 minus 575 gives me a negative 10 over 1 minus 0 is 1. So negative 10 divided by 1 there gives me a slope of negative 10. So there's my slope. I can also find my y-intercept easily. There's my y-intercept, because it's the point that goes along with 0 on my x's. So here's 0 seconds, 575. So my y-intercept is 575. When we talk about which person to compare them has the higher slope or the greater slope, think about the fact that we're descending. We are hang gliding, so we're going downwards, and we're going to think about which one is going downwards faster. And in this case, our negative 15 slope is going downwards faster. So I can write that. Fred is descending. He's going downward, descending faster. Then I'll compare the y-intercepts, and I want to decide which ones started higher up when they were hang gliding. So if I see my y-intercept here is 700, and my y-intercept here is 575, I can tell immediately that Fred, who's represented by my equation, started higher up. So Fred started higher up. Okay? Then we have a follow-up question. Which person will reach the ground first? Well, in this situation, we can do that pretty easily. So we're going to look, first of all, at Fred's information. So we already talked about Fred. He started 700 feet up, and he's going downward at 15 feet per second. So if we wanted to figure out the time it would take him to get all the way to the ground, all we need to do is take that 700 feet and divide it by the 15 feet per second. So 700 divided by 15 gives me, let me see 1 second here, 700 divided by 15 gives me 46.67, and I rounded there. So 46.67, we see that our time is in seconds, so that will be seconds. And then we've got Gene. So Gene is going at a slope of negative 10. He's descending 10 feet per second, and he started at 575 feet. So we'll take 575 feet and divide it by 10 feet per second. When we divide that, we get 57.5, so 57.5 seconds. The question asked which person will reach the ground first, so which person will reach the ground in the lower number of seconds? That would be the top function, our friend Fred. So we can say Fred. There. He'll reach the ground first. Alright, I'm going to go ahead and turn this over and we'll work on one more example. So here's another real-world application. We've got a whale this time. He is breathing, so he's coming to the surface of the water. And he's going pretty quick. He's going 80 feet per minute, and he started at a depth, so down below the water, of 1,000 feet. He, whale number 1, is going to be represented in this function right here with the equation. Another whale ascends, so again it's going up to the surface of the water, as shown in the table. So that's the second whale. So this is whale number 2. Where can I write that? Another whale. So here's whale number 1, whale number 2. Find and compare the rates of change in initial values of the linear functions in terms of the situations they model. So again, finding the slope, finding the y-intercept, and comparing them. Here we've got our whale number 1. He's got a slope of 80, and he's got a y-intercept of negative 1,000. He's 1,000 feet below the surface right now. So he's starting in the negatives and going towards the surface of the water. Then we look at our next whale, and we're going to use our slope formula. So we'll pick 2 points, maybe 0, negative 800, and 1, negative 700. So I'm going to go over here with 0, negative 800, and 1, negative 700. And I'm going to use that in my slope formula. we should know by now it's y2 minus y1 over x2 minus x1. Fill that out with the information that I know. So y2 is going to be negative 700 minus y1, which is negative 800. Make sure we get that minus negative in there. Minus from our formula, negative from our point. And then we've got x2, which is 1, minus x1, which is 0. So negative 700 minus negative 800. Remember, every time we have a minus and negative, we do the opposite. So it's like adding. So this problem is like negative 700 plus 800. And negative 700 plus 800 gives me a positive 100. On the bottom, 1 minus 0 is 1. Makes a pretty easy division problem. 100 divided by 1 is just 100. So the slope of that whale is 100. It's going towards the surface of the water at 100 feet per minute. His y-intercept is pretty simple as well. We look along our x for the spot where we have a 0. 0 goes with negative 800, so our y-intercept is going to be negative 800, telling us that he started 800 feet below the surface. When we compare those, we can say whale number 1, he's going slower. He's got a slope of 80, whereas whale number 2 has a slope of 100. So whale number 2 is going quicker here. And then we've got a y-intercept of negative 1,000, and here we've got one of negative 800. So whale number 1 is starting deeper too. He's starting 1,000 feet below the surface, and whale number 2 is only starting 800 feet below the surface. So when it asks us which whale will reach the surface first, we could use math, we could use division like we did before, but we could also just use some common sense here. This whale, whale number 1, starts deeper, and he goes slower. Whale number 2 starts shallower, and he goes quicker. So it makes sense that whale number 2 is going to reach the surface first, since he starts shallower and he's actually going more quickly there. We don't need to do any math there at all.